Hi everyone, welcome to this tutorial on presenting quantitative data. One of the easiest ways to present data with lots of numbers is to summarize those numbers into something called a frequency distribution. The definition of a frequency distribution is a summary table in which the data are arranged into non-overlapping categories or class groupings. You will see that this is very similar to how we present categorical data, except that here we are dealing with numerical data or numbers that don't fall into specific categories. So we need to follow a few extra steps to set the data up into these categories, or what are called class groupings. Here we have data compiled from Forbes' list of the world's wealthiest people. What I did was to take the top 100 wealthiest people and enter the data into a spreadsheet with each billionaire's name, net worth, age, country of citizenship, and gender. The data was taken from this website where it is spread out even more colorful and in more detail with pictures and hot links, but it also makes it harder to get a sense of how these billionaires are spread in terms of age, gender, country of citizenship, and so on. It would definitely make it much easier for us to understand the data if we could summarize it using a frequency distribution. Now, to set up a frequency distribution, the first step is to define the classes. Let's say, for example, that I would like to summarize this data into age categories so that instead of looking at 100 different values for ages, I can look at, say, 5 age categories ranging from youngish to young middle age to middle age, middle age, older, even elderly. I'd have to work on those categories. But if you take a look at these 13 that you can see on this slide, the first is 59, the second is 84, the third is 74, and we have 100 of these numbers. So how do we go about assigning these numbers to age categories? Well, the first step is to define the categories, or what we call class groupings. So here's step one. Step one is to select the appropriate number of class groupings. And as a rule of thumb, we don't do less than 5, and we don't usually do more than 15 or 20 class groupings. Next is step two. Step two is to determine the width of the interval. So let's say we decide on 5 age categories. How many years are within each category would be the width of the interval. So to calculate the width of the interval, we use this formula, range divided by the number of class groupings. Now remember what range is. Range is your highest number minus your lowest number. So in our example, that would be the oldest person minus the youngest person divided by 5. Step 3 would then be to define the non-overlapping class boundaries using the width of the interval that we just calculated. So let's see how this is done. Okay, step 1, we'll start with the 100 wealthiest people, and we're going to decide to use 5 class groupings. There's no right or wrong to this choice, but think about how many categories you want to break the ages into so that it represents the data in the way you want. So let's say that I want 5 class groupings. The next step is to calculate the width of the interval. Remember, the formula is range divided by the number of class groupings. So the oldest person was 95, the youngest person is 30. So 95 minus 30 is 65, divided by 5. 65 divided by 5, we get 13. Now we could stick with the number 13 as the width of the interval, but it's a rather odd number to split ages by, so let's round that up by 15. Again, this is your choice when you're creating these class groupings, but you want them to be in a conventional form, and the way most people think is in terms of intervals of 5 years or 10 years or 15 years, not 13 years. So it just makes more sense to use a width of 15 instead of the 13 that we calculated. Since the youngest billionaire is 30, we can start the first class grouping at 30. We could also start it at 25 if we want. That's again your choice. We calculated the width of the interval to 13 and rounded it up to 15. So the first class grouping would be from age 30, and then the width of the interval is 15, so between 30 and 45. So we would write that out as 30, but less than 45. The next class grouping would be 45, but less than 60. Okay, 45 plus 15 is 60. 60 plus 15 is 75, so the next class grouping would be 60, but less than 75. 75 plus 15 is 90, so 75 but less than 90. and then we have 90 but less than 105. Notice we say but less than 45, since we can't have a class grouping of 30 to 45, and then the next class grouping would be 45 to 60, then you'd have the number 45 in both categories. And where would you put a 45-year-old? Would they go in category 1, which is 30 to 45, or would they go in the second grouping, which would be 45 to 60? So you have to write it in a way that it is non-overlapping. So 30 but less than 45 means up until the age of 45. If somebody is 45, then it's clear that they go into the second age category. Those are called limits or boundaries of each classes, and you have to make sure that they don't overlap. That's why the definition for a frequency distribution specifically says that we are splitting the data into non-overlapping categories. We can do this easily for 100 or even 1,000 numbers using the pivot table tool in Excel. Here are the steps that you'll need. You can pause this video and write down these steps, but let's demonstrate it by actually doing it. All right, here's the data on our Excel spreadsheet. So let's click the range of cells, and we're going to do a frequency distribution on age. Okay, so I'm selecting the entire range of ages all the way down to the last one. Okay, now let's click on Insert. Let's click on Pivot Table, and it shows me the range that I just selected. I can enter a different range. That's the correct range. It also says choose where you want the pivot table to be placed. I clicked New Worksheet. That's actually the default setting. Click OK. All right, now over here you drag the age to the rows field and drag the age to the values field. And now we click on the sum of the ages and we click on the value of the field settings right here. And we want to change the sum, we want to change the sum to count. Click OK. And now you can see a frequency distribution of all the ages. Take a look at that. I'm going to scroll down and you can see, for example, age 57 had a frequency of 6. That means 6 people were age 57. Let's see, the oldest person is 95 and there's one person 95. There are 2 people 92. There's one person who is 90. So this is how we can use Excel's pivot table tool to create a frequency distribution so that we don't have to count these ages by hand. Now, even though Excel did a nice job on giving us a frequency distribution, it would be easier to read the data if it was grouped into classes, and we had already decided to group the classes into 5 categories. So here are the steps to do that using Excel. You right-click into any of the cells containing the age, you choose Group, Starting Box, Ending Box, and by 15. So copy these down, pause the video, and let's take a look at how it's done in Excel. All right, let's take a look at how we can use Excel to group this frequency distribution table into 5 categories. So what we do is we click on any of the cells that have the age in it and right click, and you'll see here choices, and one of the choices here is group. All right, so you clicked on a cell that has the age, you click on the option group, and then it says starting at and ending at, and it already filled it in the way I wanted, which is starting at the age of 30, ending at the age of 95. I could change that to end at the age of let's say 104. All right, and then we want the groupings done by every 15 years, not 115, every 15 years. All right, so click OK. And now we have the groupings, and I have it set up with the width of the interval exactly as I had written it out by hand, but here Excel did it for us. Okay, so once again we can see the steps. They're very easy steps, and so a very tedious task becomes very simple using Excel. And we get a nice neat table using the group option. And I jazzed it up a little bit here, but that's basically what Excel gave us. Let's talk a little more about what a class limit is. A class limit is chosen so that all the data fits into mutually exclusive and collectively exhaustive, non-overlapping categories. Now that's a real mouthful, so let's see what I just said. Mutually exclusive. That means if something is in one category, it can't be in another at the same time. So if you are in age category 30 to 44, you can't also be at the same time in another age category, say 45 to 60. Collectively exhaustive. What does that mean? Well, it means that collectively all the class groupings exhaust all the possibilities. That means that there is no one younger than 30 or older than 104. If there is, then we didn't take into account all the possibilities when we constructed the class groupings. In other words, 100% of the data must fall in these 5 class groupings. Another term you need to be familiar with is the class midpoint. This is the number we frequently use to represent a class or a category. It is the number that is midway between the lower and upper class limits. So for our example, the class midpoint for the first category would be halfway between 30 and 44, or 37. We can also construct a relative frequency distribution. The formula for this is the frequency count of each class divided by n, the total number of observations. This will give us a relative frequency, also known as a proportion. The percent frequency distribution would take the proportion we just calculated and multiply it by 100 and turn it into a percentage. Here is how it's done for our wealthiest 100 people example. Since we have 100 people, we take the frequency count for the first category, or 5, and divide it by 100, the number of people, to get 0.05. When we multiply this by 100, we get a percentage, or 5%. We can summarize all of this information into a table that shows the frequency counts, the relative frequencies, and the percent frequencies. You can see how neatly all the data fits into this tabular format. It's much easier to read it as shown here than scrolling down an Excel spreadsheet with 100 rows. Another way to summarize the data would be to use a simple graphical tool called a dot plot. Here, a horizontal axis is used to show the range of the data, and the dots represent each data value. There should be 100 dots on this graph, and you can see the dots furthest to the left, while the dot furthest to the left is on 30, and the dot furthest to the right is on 95. So that represents the youngest and oldest people in our data set. There may be less than 100 dots shown here because it's in 2 dimensions and some of the ages repeat themselves, so some of the dots are one on top of the other. And one more graphical tool we can use is what is called a histogram. Yes, it looks like a vertical bar chart, but there's a fundamental difference between a histogram and a bar chart. With a bar chart, there are gaps between the bars, if you remember, since a bar chart represents categorical, non-quantitative data. A histogram, on the other hand, represents numerical quantitative data that is continuous in nature, and therefore there are no gaps between the bars. Don't forget, when you're constructing any chart, whether it is a bar chart, a pie chart, a dot chart, a histogram, any type of chart you can imagine, make sure you give your chart a title and clearly label any of the axes. You can see here the title at the top says Histogram of Ages of the Wealthiest People, and the axes are labeled Frequency and Age. There is one more thing we can do with this data to change the way it is presented, and that is to calculate the cumulative frequencies for each category. What does it mean, cumulative? My students know this term very well, since every semester I get the same question around finals time. Professor, is the final cumulative? So we all know what the term cumulative means when it comes to final exams. It means, is the final on only what we covered since the last exam, or is it on everything from the beginning of the semester, even material that was covered on previous exams? Well, the same holds true for any categories we want to present as cumulative. A cumulative frequency distribution shows the number of counts with values less than or equal to the upper class limits of each class. That means we include in each category the frequency counts in that category and all the counts in the previous categories. So let's take a look at our age categories. We had a frequency count of 5 in the first category, so the cumulative frequency would be 5. Then we have 25 in the second age category. So 25 plus the 5 from the category before it would be 30. Then the next age category, 60 to 74, has 35 people. So that 35 plus the 25 and the 5 before it would make 35 plus 30, or 65. The next category has 31 people. Add that to the 65 and we get 96. And then the last category has 4 people, so add that to 96 and we get 100, which is the total number of people. So the last column shows the cumulative frequencies for our ages, and we can see that each category adds from the previous categories so that the last category has 100 people in it, and that is how we construct a cumulative frequency distribution. Here is a comparison of the two tables we created. The top table shows the frequency, relative frequency, and percent frequencies for the age data. The bottom table shows all of these as cumulative distributions: cumulative frequency, cumulative relative frequency, and cumulative percent frequency distributions of the age data. One more powerful graphical tool that also preserves the original data as it is showing a graph is a stem and leaf display. It is going to look like a horizontal bar chart, but instead of bars, we will have numbers. Here is what it looks like. You can see a vertical bar that separates the leading digits and the trailing digits. The leading digits are the numbers to the left of the vertical bar. That is called the stem. The digits to the right of the vertical bar are the trailing digits, and these are called the leaves. The data is usually split, so the last digit of the numbers make up the bars or the leaves on the stem and leaf display. This concludes the presentation on tabular and graphical displays. Up until this point, we have only discussed how to present data for a single variable. To understand how to present data for 2 or more variables, please watch my next tutorial on summarizing data for 2 variables, where I will discuss cross-tabulations, scatter diagrams, and stacked bar charts. Hope to see you there in my next tutorial.